Hey everyone, welcome back to my Calculus 2 series. In today's lesson, we're going to be talking about the root test. This is going to be a pretty quick video on just another test that we can use to test the convergence or divergence of a series. So this is the root test, and as you can see, these three conditions look very similar to the ratio test, and essentially it is almost the ratio test, just kind of with a different little twist, and we're basically testing different types of series. So the root test says that if we have this series right here, and it basically sums up all the terms a of n, if we take the nth root of the absolute value of that series, and then we take the limit as n approaches infinity of that, we're going to get this value L, or the value of the limit. If that value is less than 1, then we can conclude that the series is absolutely convergent. And in the second condition, we say that, well, if we do the same process, we take the nth root of the absolute value of n, and then we get that L is going to be greater than 1, or it's equal to infinity, then we can conclude that the original series is going to be divergent. And like we said in the ratio test, if that L value is going to be equal to 1, then the root test is going to be inconclusive. So that's all there is to this test. It's basically these three conditions, and they're very similar to the ratio test, so you shouldn't really have a problem memorizing them. For the example, I'm going to show you example series, and basically these are the types of series that we want to apply the root test to. They're very distinct. You're gonna recognize them immediately, and basically if you see a series with a power of n, then we're going to use the root test. It's a really big giveaway if we have something to the power of n. Here's the series, and again, like I said, we have this whole term to the power of n, and that's the biggest giveaway that we are going to be using the root test. So, well, how do we go about it? So the root test tells us to compute the limit as n approaches infinity of the nth root of the absolute value of a of n. So first, let's find what a of n is. So a of n is equal to all of this stuff right here inside of the sigma sign. So basically it's the 2n plus 3 over 3 times n plus 2, and all to the power of n. So now if we look, we need to find the absolute value of a of n. And in this case, it's just going to be the absolute value of all of this. However, as you could see over here, because n spans from 1, and n is basically always going to be positive, it's from 1 to infinity, both the numerator and the denominator are going to be positive because, well, there's no negatives. Like 2 times a positive is still going to be a positive, 3 times a positive is still going to be a positive, and then we're adding 2 positive values. So basically the base, like if we think of this as base to the n, where n is this and then this is the base to the n, this is always going to be positive no matter what the value of n is, because again, b is always going to be positive. So this absolute value is kind of useless. We are basically left off with the same term that we had. And well, now all that's left to do is to find this term right here, which is the nth root of this value. So if we find the nth root of the absolute value of a of n, then we want to take the nth root of this. So we take the nth root of 2n plus 3 over 3n plus 2 to the power of n. And as you can see, these n's will cross out, and that's exactly why we wanted to use the root test. And all that we'll be left with is 2n plus 3 over 3n plus 2. And now we want to take the limit of that, so of 2n plus 3 over 3n plus 2. And as you can see, this limit is going to go towards 2 over 3 again, because this is the dominant term and then this is the dominant term here. This right here is going to be that L value, and as we could see, that L value is going to be less than 1, meaning that this series is going to be absolutely convergent. So that's it for this quick little video on the root test. Again, it was just another test that we could apply to these very specific kinds of series to figure out whether they're absolutely convergent or divergent. Hopefully you guys enjoyed this video. If this video has helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I'll catch you guys in another video.